In this lesson, we're going to continue to use the formula for compound interest, but we're going to get questions that are going to ask for the present value or the starting value. So remember that P is the starting amount or the initial value. It's the P for principal, so principal means the starting amount. And so some questions might ask you to find P, the starting amount, and not A, the end amount. So we can rearrange the formula to get P by itself, or we can put in the numbers and then isolate for P once we have in all the values. So if we isolate for P, we're going to take the formula and we want to get the P by itself, so that means that we want to divide by this bracket, and we're going to do the same on the other side. So on this side, those will cancel, and you'll end up with this formula here. So P is the end amount divided by 1 plus I to the n. Remember that I is the interest rate per compounding period. We always write that as a decimal, and n is the number of compounding periods. So I and n are very important depending on how often we are compounding. So here's an example. We have an investment that is earning 6%. We know it's compounded semi-annually, so that's twice a year. And it says how much must be invested today, which means what are we starting with if we want 8,000 in 5 years' time. So in this example, our end amount is 8,000. That's what we want to end up with. The interest rate is going to be 6%. That's going to be compounded semi-annually. So our 6% will be divided by 2. And then n is total number of compounding periods. So it's semi-annually, which is twice a year, and we're doing this for 5 years. So n is going to be 10. So if we want to find the principal, the start amount, we're going to take the end amount. We're going to divide by 1 plus I to the n. So in this example, our end amount is 8,000. Our interest rate is 6%, but we are compounding that semi-annually, so we'll divide that by 2. And then we're going to do that 10 times, twice a year for 5 years. And then we're just going to plug that into the calculator. So let's see what we get, 8,000. And you can do it in steps if you want. So 0.06 divided by 2 is 0.03. And then we're going to do 0.03 to the power of 10. And we get a starting amount of 59.52 and 75 cents. So we want dollars and cents. So that makes sense because we should be starting with less than what we're ending up with because we are earning interest. So we're starting with just under 6,000. After 5 years, we would have that $8,000. First, we got a value of 59.5275. Okay, the second example, find the amount needed to be invested today. So that means we want the starting amount. This time we want $10,000, so that's our end amount. In 5 years at 2% compounded quarterly. So my interest is going to be 2% compounded quarterly. So that's 4 times a year. So 2% 4 times a year. The n is going to be 4 times a year, quarterly, for 5 years. So n is going to be 20. So our principal will be $10,000 starting amount. Interest is 2%, which is going to be quarterly, and we're going to do that 20 times. So let's see what we start with. So 2% divided by 4, we're going to add the 1. So that's going to be 1.005. Or maybe I'll write that as a second step. So I'm just going to do the bracket. And we want that to the power of 20. So we'll do $10,000 divided by 1.005, and that is to the power of 20. And, oops, calculator made a mistake there. 1, 2, 3. Okay, let's try this again. Calculator died. Let's try this. 10,000 divided by 1.005 to the power 20. So that's 9,050. And what was the cents? And 25 cents. And 63 cents. And that seems reasonable. Again, it should be less than 10,000 because we're starting with a smaller amount and then we're earning interest. Did that first. Okay, next example, we have how much needs to be invested today, so present value, in order to have 50,000. So our final amount needs to be 50,000. We have 3% compounded monthly. So 3% monthly. So we're going to change that to a decimal. And then N is going to be monthly, which is 12 times a year for 10 years. So N is going to be 120. So our present value will be the end amount divided by the interest rate divided by 12. And then that's all going to be to the power 120. So let's see what we get. Maybe we'll do the bracket first. So 0.03 divided by 12 plus 1. So you can put it all in your calculator at once, or you can do it in steps. So I have divided 0.03 by 12 and added 1. That works out to be 1.0025. That's going to be to the power 120. So we're going to do 50,000 divided by 1.0025 to the power 120. Oh, that was a 20. And the present value is going to be $37,054.78. So again, it should be less than 50,000 because we're earning interest for 10 years. So that seems like a reasonable amount. And you can always take your answer and put it back into A equals P1 plus I to the N if you want to check. You can take your final answer, put it in for P, calculate, and see if you end up with $50,000. And we do have something that is some software you can use to check your answers. It's called a TVM solver. TVM is time value money calculator. So it can be found on the internet, and it's just a tool that does the calculations for you. And you can use it to check your answers. So you'll notice in the TVM solver we have an N. So N is the same as the N in your formulas. So N is the total number of compounding periods, just like it is in the formulas. Then we have an I, an interest rate. So the interest rate you just put in to the TVM solver as it is. You don't have to divide it. It will do it for you. So you just put in I. PV is your present value or your principal. So that's what you're starting with. Payment we're not going to worry about right now because we're going to do that later when we do annuities. So payment would just be 0 because we're not making a payment. FV is future value. So that's your end amount. That's your A. And then PY is payments per year. And CY is compounding per year. Those tend to be the same. So if we're depositing monthly, we're also earning interest monthly. So for the questions that you're going to do, these are going to be the same. Sometimes they'll be different, but that's where the TVM solver is useful because it can do that for you. It can have 2 different payments and Okay, so let's use one of the examples that we just did. So this is the first example. So if I was putting it in the TVM solver, my N would be total number of compounding periods. So remember, it's semi-annually for 5 years. So that's going to be 10. My interest rate would be just the 6%. So you don't have to do anything to that. It will do it for you. Present value is what we're looking for. So put a question mark. Payment we don't have to worry about because we're not doing a payment. That will be in a later example. Future value is what we wanted at the end, which is 8,000. Payments per year and compounding per year are both going to be 2 because that is, we're going to earn interest semi-annually and we're going to be paid interest semi-annually. So those tend to be the same. So payments per year and CY are both semi-annually. And then we would just put in our cursor at present value. And then we would just click solve for PV. Right, so that's right here. And we would just click on that and it would give us the answer. And the answer it's going to give us is the same one that we got using our formula. So remember back with the form, if you put these in here, you should also get a value of 59.5275. So you should get the same answer. You should be able to check that using your TVM solver.